Okay, labas ratas, everyone. My name is Steven. This is problem set 9, and I'm doing problem number 3. Let us begin. So, the first part of the problem says, we're going to read it this time. A ladder of length rad 15 meters is resting against a vertical wall. Let's draw that. So here's a ladder. I'm going to draw it this way. Everyone else drew it the other way in class, but I'm going to draw it this way. And it's rad 15 meters. Okay? And here's our vertical wall. So I guess someone's putting up Christmas lights or something. Okay, so we're going to erase that part of the problem now. So it doesn't confuse us. Okay, next part of the problem. This creates a right angle T with the ladder as the hypotenuse. Okay, so here's the ground. I'm going to draw the ground too. And this creates a right angle, which the problem calls T. Okay, now, can you see that? Yes, you can. Okay, so, and the wall is the ground is the legs. So these are now legs of this right triangle. Okay, cool. So let's get rid of that now. Hopefully we can do this in one take. Okay, so there is a point on this ladder that is exactly 1 meter from the ground and 1 meter from the wall. So we will take this rad 15 ladder. I guess that's the ideal length of a ladder. And this point looks about 1 meter from the ground and 1 meter from the wall. Okay, and this is the shortest distance is perpendicular. So this creates like a square. 1, 1, 1, 1. Cool. Okay, let's erase that part. Cool. So, let's look at this diagram here. I like it, but there's some unknown lengths. So I think I'm going to fill it in. I'm going to call this one Y and this one X. So this is the part of the leg of the triangle that is not accounted for in this 1 meter. All right? So now what do we need to know? We need the purpose of solving this problem is to find the sum of the lengths of the two legs in triangle T. I guess this is triangle T. Okay. That's right, because you name a right triangle by the point of its right angle. Yes. Okay, so we want the sum, so that would be x plus 1, that's this leg, plus y plus 1, which is this leg. Okay, so this will be our solution. Great. So now that we are done with the problem, let us figure out how to solve it. Okay, so right triangles and Pythagorean theorem go together very nicely. So we're going to perform the Pythagorean theorem on this right triangle. That is usually the first step. So I'm going to take the big triangle and say this big leg, y plus 1 squared, plus this other leg, I guess it's not the big leg, whatever, squared, is equal to the hypotenuse squared, or rad 15 squared, which is 15. Okay, so now after doing some math, y squared plus 2y plus 1 plus x squared plus 2x plus 1 equals 15. Now when we do that, okay, we're going to do more calculations then. Y squared plus 2y, we're going to take away all of the constants since we can group them on the other side, plus x squared plus 2x. We're going to subtract 1, so subtract 2 from 15, that leaves 13. With me so far? Now at this point, everyone's going to be like, oh, x squared, y squared, we need another equation. I was like that in class too, yeah. But we're gonna now that we know the way to do it, we're gonna make it easier. So first we're gonna group the x squared and the y squared together. Right? And then we're going to group the x and the y together. And we're going to factor it. So that's 2 times x plus y equals 13. So this 2x goes there, and this 2y goes over there. So now, we have this x plus y here, and this x squared plus y squared here. And it would be awfully nice if x squared plus y squared factored into just quantity x plus y squared, but it doesn't. But we can make it do that. You see, if we can get this in terms of all just x plus y, we don't have to find x and y individually. We can treat the quantity x plus y as its own variable and factor it and find the solution to x plus y. So, in order to make this into like x plus y squared or something like that, we need to complete the square. And so, completing the square, this is x squared plus y squared. The middle term would be 2xy. So plus 2xy plus y squared. And we're going to add that to both sides because of whatever that theorem is, or whatever you call it. Property of equality. 13 plus 2xy. Very good. And this is beautiful because it factors now into x plus y, quantity squared, plus 2 times x plus y equals this. 13 plus 2xy. Okay, so now on this side of the equation, we're almost ready to like factor it, which is amazing. But the problem is this xy term. No one likes that xy term. What are we going to do with that xy term? I'm going to show you what we're going to do with that xy term over here, because you can see that. Okay, so using the information we have here, we can find xy. If we couldn't find xy, this solution would be pointless and we wouldn't be able to solve the problem anyways. But since we can find xy, I'm going to do it two different ways. Okay, so the first way is by similar triangles. Okay, yeah, I spent a lot of time finding xy is equal to 1, but this other thing came later. All right, so similar triangles. So in this triangle here, we have two smaller right triangles. And it would be nice if they were similar, and it turns out they are. So we can prove that using, you see these two lines here are parallel. And so this line that goes through them creates two corresponding angles here, one here and one here. And so we know that they're the same because this line is intersecting two parallel lines, and that corresponding interior, whatever geometry called it. And so then, because in a right triangle, this angle is the same in both, because this is 90, so this has to create two complementary angles, so they're the same in both. That means they're similar by the definition of similar triangles. So, since they're similar, we can create proportions. So I'm gonna call. Okay, so let's. Can we see this still? Yes, we can. So we're gonna call this the Pythagorean method. Pythagorean method. Okay, so that's the Pythagorean. Can you read? Yeah, okay. So Pythagorean method here. And then we're going to go over here and we're going to do similar triangles method over here. Okay, so that's proportion. So we take x, and that is opposite of this double angle here I wrote. So that's corresponding to 1 over here. And then the y is opposite the single angle, and so that's corresponding to its other one. Wait, no, I'm sorry. Yes, well, okay, that does work. But, okay. Because this is from the same triangle. Okay, I did that, whatever. Okay, so xy when we multiply is equal to 1. That's one way we can get xy is equal to 1. I kept getting that in class, I don't know why. Okay, the other way is by the area method. And so the area method doesn't require us to prove that they're similar. That's why we like the area method. So, we can find the area of this triangle two different ways. And since we can find it two different ways, we can set up an equation to find it two different ways and set them equal. And that'll give us what we need. And so, here's the area method. And the area method says that 1/2, the area of a triangle, x times 1, plus 1/2 y times 1, is equal to the area of the big triangle, which is 1/2. Oh, right. Plus this 1/1 square, plus 1 times 1. And then that will add up to the total area of the big triangle, which is just x plus 1 times y plus 1 times 1/2. I forgot that. Okay, so I don't like 1/2, so I don't like fractions, so let's multiply the whole thing by 2. Shorthand for that is that. And so we're going to get x plus y plus 2 is equal to this. And so let's FOIL this out too while we're at it. xy plus x plus y plus 1. Okay, and so now it's awesome because when we subtract the x, oops, that's a bad x. When we subtract x, subtract y, subtract x, subtract y, and we subtract 1 from both sides, we get 1 is equal to x times y, or what we got up there. So that's the 2 different ways to get that. But basically, shoot. Are you still rolling? I don't know. Oh well, we'll complete this anyways. The error, so right, we know that xy is equal to 1. And so, this is no longer a problem. So let us go over here and say 13 plus 2, that's xy, is now 15. So that is what that is equal to. And so now we're going to go up to the top, because I ran out of room kind of. And we're going to go here. And so now, watch this. I'm lazy. If you want to see someone H-sub, look at Hannah's video. But I'm just going to factor this. Minus 15. So I subtracted the 15 over to the left side of the equation, right? And so now we just factor this normally using xy as our normal x squared, right? So that's x plus y, right, x plus y, not xy. Minus plus 5 times x plus y minus 3 is equal to 0. And so, as you can see, x plus y, this quantity, can either be equal to -5 or x plus y can be equal to +3. So if x plus y is equal to -5, we will have an imploding triangle, and we don't like those. So not equal to -5. It is equal to +3. Knowing that, we know that x plus y is equal to +3. You can see that, right? Yes, you can. And so, remember this was the answer. Was this thing, which is just the sum of the lengths of the legs. And so if we go over here and we're like, oh, let's get rid of the parentheses and take the x and the y together. And we're like, oh, we know that that's 3. And then we have 2 1s left over. And that's equal to 5 meters, because we're in meters. And that is the answer to the problem.